All right. Hello, statistics children. So we are moving right along with our regression unit about scatter plots. And today we're going to sort of introduce least squares regression lines. This particular lesson has a lot of, I want you guys to try stuff and then talk about it. So this recording might be kind of long. Just have fair warning. And also, just in case, I don't remember what I put for this, but this is not a one-day lesson. This is a multiple day lesson. So just keep that in mind. So we're going to start off today like this. You guys last lesson looked at talking about slope and y-intercept of a line of best fit, or a least squares regression line. For this lesson, we're going to actually look at how to get that regression line. And even so, we're not going to ever get it by hand. We're going to make our calculator get it for us. But before we kind of get into how we do that, I want you guys to kind of play with regression lines so that you understand the idea of where they come from. So if you have a phone, which I'm betting most of you do, I have a website that you can go to up here. It's in blue. And I would like you guys to essentially try this activity. So I'm going to ask you to pause this video, try the activity, actually follow steps 1 through 6, and then actually answer questions 7 and 8. And do 9 as well. You should be able to do that as well. So basically do 1 through 9 yourselves with either individually, or if you'd like to work with your group, you can do that as well. And then after you've done that, you can restart this recording so we can chat about what you came up with. Okay, so go ahead and pause it right now. In the meantime, I'm going to actually go to this website and do a couple of these for you so you kind of have clarification of that. Okay, so pause this, try to follow all the instructions. If you're a little confused, start the video again, check out what I'm doing, and then pause the video and do your stuff. Okay. So I'm going to go ahead and go to the website, which now I am at here. I've already input all of the points I told you to. So for example, the first one was 1, 2. And so to input points, you just type down here, 1, 2, and then put add point, and it will add the point. So at the end, your graph of just the scatter plot should look like this. Next, you're going to choose show guess. You are not going to choose show line of best fit. And what this is giving you is it's going to give you an equation of a line. And what you guys are going to need to do is you need to kind of mess with the equation a little bit to get this purple line to fit as much of the blue data as possible. So hopefully you did this already. If you haven't done this yet, or if you're kind of confused as to where to go, to tweak this line, you're going to tweak the numbers in the show guess equation boxes. So for example, this equation, this purple line is centered at 0. So that's the y-intercept is at 0. And I'm noticing that's a little low. I would kind of like to shift this line up a little bit so that it goes through more points. So I'm going to change my y-intercept from 0 to 1 and just see if that kind of helps. So I've now shifted it up. It's at 1 now. That's a little better. Maybe I'll shift it up to like 2. That's a little better even than it was before. So now I'm going to mess with the slope, because this line I feel like could go through more of the points. In fact, I'm looking at these 4 points right here, and I would really like this line to go through those 4 points. So now I'm going to mess with the slope. I need this line to kind of be a little flatter, so I'm going to make the slope less than 1, so maybe like 0.5. I'm going to try that. Ooh, that's a little too low. So maybe let's try 0.7. Okay, that's better. And then I can actually shift this line up a little more maybe. So maybe like 2.5. Let's try that. Ooh, that's looking good. It's looking good. So now I've created a line that I think fits the data pretty well. It goes through some of the points. It's pretty close-ish to the ones not lying on the line. Admittedly, this guy up here is kind of far away, but that's good enough. So that's sort of what I want you to do. Now, some of you might actually come up with a different equation than I did, and I'm going to tell you straight up my equation, y equals 0.7x plus 2.5. That is not going to be the line of best fit. So play with it a little bit and see what you get if you haven't already, okay? So again, if you want to pause here and just kind of play with it, you go ahead and do that. You would write your equation right here on number 4. So you're going to guess your equation. And then once you've guessed your equation, let's see how close you came. So for mine, I'm going to put show line of best fit now. Oh man, I was close. Look at me. Hey. It's like I've done this before. So the line of best fit, the actual best fitting line is this guy. Y equals 0.82x plus 2. Now I was close. I had 0.7 instead of 0.8. And I had plus 2.5 instead of plus 2. But I was pretty close. Okay. So going back to your... play this here. Going back to your note sheet here. Let me grab some pens. There we go. So my line that I chose was 0.7x plus 2.5. The actual equation was y equals 0.82x plus 2. And actually, if you notice, this is not the correct form for AP Statistics. In fact... Dog, really? It's the mailman. Calm down. So in fact, my y, oopsie, hold on. Let's wait for their computer to be stupid. Good job. My y should have a hat, and my slope term should actually be second, and I should be starting with my y-intercept. So y hat equals 2 plus 0.82x. So that should actually be my statistics form of that line. Okay. So it says, check out the point 6,9. Exactly how far off is this line from the line of best fit? So going back to our original guy. I'm going to take off the show guess. So now I'm looking at the line itself. So I'm going to look for the point 6,9, which is the, oopsie. What did I just do? Hold on, pause. Okay, never mind, I lost it. Okay, so going back to your line, find the point 6,9. I want to know exactly how far off is that point from the line of best fit. And so the way that you could check that is you could kind of eyeball it. So you have the line, the points above the line, about how far is the distance from that point to the line. And I will tell you the actual distance that you should have got was 2.08. And if you're wondering, hey, how on earth did you get that? Well, you got to do a little bit of algebra. So this is what I did. So I know I was looking at the point 6,9. So my x coordinate was 6, my y coordinate was 9. But what I wanted actually, I wanted to find, let me change colors here for you. Pen, do your job, pen. Thank you. Okay. What I want to find actually is not the y coordinate. That's actually the location of this point. I want to know, hey, if that point was on the line, where would it be? And so what I'm going to do here is I know that the x coordinate is 6 because I'm looking at the point 6,9. And so I'm actually going to plug in 6. I'm going to plug in 6 for x to this equation, and that should give me where exactly on the line this point is located. So I'm going to do y hat equals 2 plus 0.82 times 6. And if I plug that into my calculator, because I sure ain't doing that by hand, I should get that y hat is about, or not about, it's about 6.92. So my y hat is about at 6.92. So this level right here, this is about 6.92. This guy is about at 9. So if I want to know how far those are apart, I'm just going to do 9 minus 6.92, which is equal to 2.08. Okay. So wanted to know exactly how far away the actual point was from the line itself. And so that's how I did that. I took the y coordinate of the point and I subtracted what the y coordinate would have been if the point landed on the line. In fact, this guy is actually y hat and this is y. Interesting. Wonder if that's going to come back. It does. Anyway, moving on. So it says it appears that the point 5, 6 lies directly on the line of best fit. Does it? Justify your answer. So how would you know for sure if this line or if this point lies directly on the line? Well, you would have to kind of do a similar thing to what we did before. If the point lies on the line, then that means if I plug in 5 for x, I should end up getting 6 as my answer. And so, looks like I didn't actually do this, so now I'm going to have to do this real quick. So plugging in all of this to my calculator, I'm doing 0.82 times 5 equals 4.1 plus 2. Oh man, it's 6.1. 6 is not technically equal to 6.1, but as you can see, they're very close. So 5, 6 looks like it's on the line, but it's just slightly off of it. So the answer would be no, it does not lie on the line. And then kind of a cool thing for AP Stats, guys. When it says justify your answer, you can write an explanation. We do a lot of writing in this class. But instead, if it's a mathy type of question, you can also just show work. And showing work counts as justifying your answer. Okay? And then finally, I wanted you to actually put in the points from number 1, from this guy above. I wanted you to actually put those points into your calculator. So all of the x coordinates should have gone into L1 and all the y coordinates should have gone into L2. If you haven't done that yet, please go ahead and do that now. Also, a couple of just kind of housekeeping procedures for your calculator. If you have stuff, if you have numbers in L1, like, I don't know. Sorry, thought the baby's crying. It is not. So if you have numbers in L1 and you want to clear those numbers, you're going to scroll up to where L1 is actually highlighted. So the L1 itself must be highlighted. You're going to press clear and then you're going to press enter. And when you do that, it should completely clear all of the numbers in L1. If you press delete to L1, it will literally delete L1. And so there will be no more L1 and it will just show L2. If that happened to you, I am very sorry. There are ways to fix that. In fact, if you just Google it, it's frankly easier if you actually see it rather than me explain it. So Google, how do I get L1 back if it is gone, if I deleted it or something. But if you want to clear L1 or L2, you scroll up to where the actual L1 itself is highlighted, press clear, and then press enter, and it should get rid of all those numbers for you. Okay? So again, if you haven't put those numbers into L1 and L2, pause this video and go ahead and do that now. Okay. Alrighty, moving on. Let's define some stuff. So, as I said, what you guys did in step 7 is a thing. It's a very big thing. It's a very big idea. What you guys did when I asked you to find the distance between the actual point and the line, that distance has a name. It's called a residual. And so the residual is literally the distance of a point to the regression line. So a residual is the distance of a point to the regression line. And even though distance can't be negative, sometimes we have them negative because that should tell us whether the point is above or below the line. So for example, this point right here is going to have a positive residual, whereas this point down here is going to have a negative residual. And all the positive and negative tells us is whether the point is above or below the regression line. Oops, to the regression line. I forgot to write the word line. By the way, guys, I don't know if I've done this yet in my videos, but I omit words when I write them. So if you notice that happened, then just add in the word that should be there. I usually omit words like the, so sorry about that, but alas. Okay, and actually the formula for the residual is precisely what you did in step 7. In fact, it's this guy right here. The formula for a residual is y minus y hat, where y is the y coordinate from the actual point, so the y value from actual point. And then y hat is what you get when you plug in x to the regression equation. So to get y hat, plug in x value to the regression equation, y equals a plus bx. Okay? And then I should say, and solve for y hat. Okay? So that is how we get a residual. Okay? So for example, we'll erase this real quick. We'll go with this guy. So for example, if I wanted the residual for this point is x comma y. The point on the line, which is what I'm looking for, this is x comma y hat. And so I would find the residual, and then again, this guy right here, the length, the distance is the residual. And again, I would find the residual always by doing y, the actual y value, minus y hat. And so if you notice, if I do the actual y value for this point minus y hat, you're going to have a lower number subtracting a larger number. So in this case, your residual would be negative. Versus up here, this guy's residual would be positive. Okay? So let's look at a problem where you would have to calculate a residual. It's really not that hard. It's just very forgettable, and so lots of times kids just forget how to do this. I cannot tell you how many times I have heard the question, how do you take a residual again? And yes, that is what you all sound like to me. Okay, so example 1. From the truck example from yesterday, so same equation. So if you need to go back and look at the equation, it's actually right here for you. So from the truck example from yesterday, find and interpret a residual for a truck that had 70,583 miles on it and sold for $2,994. So first, given what you did in step 7 above and given this definition here, I would like you guys to pause this video and actually try to calculate the residual yourself. And if you think you pretty much know what a residual in this case would be, if you feel confident interpreting it, go ahead and interpret it. Or if you're afraid to write it down, at least tell somebody at your group what you think the interpreted residual is. That way, if you're right, you can be like, oh my gosh, guys, I win. Okay? So go ahead and pause this. And then we'll go over it after you resume. Although I'm going to just plunge right ahead. Okay? So we'll see what you got in a second, but when I'm calculating a residual, I need to know 3 things. So I need to know x comma y, and I need to find y hat, okay? Well, I know the x value that I'm looking at, according to this graph, the x value should be miles driven, which means the x value that I have is the number of miles that I have. So 70,583 miles, and then the price, the actual price, the y value, is the 21,994. That's sort of a confusing comma. I'll make a bigger comma there. There we go. So now I have x, I have y. I just now need to find y hat because I need the y hat in order to calculate a residual. Well, according to the regression equation, y hat is equal to 38,257 minus 0.1629 times x. So I have x, it's right here. So I'm going to plug in that x value to get my y hat. So do 38,257 minus 0.129 times the x value. So 70,583. Okay. I'm going to plug that into my calculator to get y hat, and it looks like y hat is going to be 26,759. Okay, so hopefully you got that. I know that the formula for a residual is y minus y hat, and so now I have my y hat, I have my y, I'm simply going to subtract them. So I'm going to do 21,994 minus 26,759, which should give me negative 4,765. So I have now found my residual. If you got that number, awesome. So now they're asking you to interpret the residual. So what does this mean? Well, this graph is talking about the price of a truck for the number of miles the truck has driven. So for a truck that has driven 70,583 miles, the price that this person actually paid for the truck was $21,000. However, the price that the person was supposed to pay for the truck, according to my line of best fit, was $26,759. So that means if this person, if this person paid $21,000, but they were supposed to have paid $26,000, what does that mean? Well, it means that person got a really good deal. It means that person paid about $4,765 less for the truck than what was expected, than they were supposed to. So I'm going to say, to interpret it, the truck with 70,583 miles cost $4,765 less than expected. Than expected or predicted. I should actually use the word predicted, since that's Y hat is predicted Y. Dog, stop walking. Coach, lay down. Relax, bud. Good boy. Sorry. I don't know if you can hear his jingling, but really. Okay. Anyway, back to the truck. So the truck with 70,583 miles cost $4,765 less than predicted. So that's how I interpret a residual. A residual tells us how much more or less something was than predicted. Now, if this had been positive, then how would this sentence change? That's right, kids. The word less would become the word more. They would cost that much more than predicted. Okay? So this is how you find and interpret a residual. So let us move on. So now that we know what a residual is, now we're going to actually officially define the least squares regression line. And we're going to define it. We're certainly not going to come up with the equation because it's calculus. So just saying. So the least squares regression line does the following. So the idea is the best fit line, the least squares regression line, the regression line, the, I don't know, model for the regression line, however you want to say it. To get the best line for the data, what you do is you calculate the residuals of all of the points on the scatter plot. So they showed you one residual here, here's another residual, here's another residual, here's another residual. And the line that is the best fit for the data is going to attempt to minimize the amount of residual. And the way that they do that is they find all of the residuals. So they find all of these residuals and they square them. So that means, like, let's say this guy had a residual of -2. This guy had a residual of like 1.5. This guy right here has a residual of like -1. They're squaring all of these residuals. And to get the line of best fit, the line of best fit will guarantee that all of these squared values are as small as they can be. Okay? So the least squares regression line comes from minimizing the squares of all of the residuals of the data. So least squares regression line comes from the line that minimizes the squares of all the residuals from the data. Okay? So that is where the line comes from. You are not going to actually be responsible for coming up with the equation like mathematically yourself, but your calculator is going to do that for you. So let's talk about how we would actually get that. So finding the equation of the least squares regression line on a calculator, actually you've already done it. It's the same place where R is located. So step one, put data into L1 and L2. Step two, press stat, scroll over to calc. That's not how you spell calc. There we go. Scroll over to calc and scroll down, or you can just press the number 8, which is linreg. And then it should say A plus BX. Do not choose number 4. That is going to mess you up. And then when you do that, it's going to ask you for an X list and a Y list. And you just got to make sure L1 is in your X list and L2 is in your Y list. After that, you're going to press enter. And it should give you, again, it'll say this, y equals a plus bx on top. And then right underneath it, it'll tell you what a is, it'll tell you what b is, it'll tell you what r squared is, which we're going to talk about next lesson, and it'll tell you what r is. They're going to give you values for a and b. So let's say that they might give you like 2.5 and I don't know, or well, actually, and we'll do that later. So they might give you like 2.5 and negative 3.1. They're going to give you the values for a and b, but they're not going to actually plug them into the equation for you because they're assuming you're smart enough to figure out that you would just put in 2.5 for a, oops, minus, and whatever the value is for b. So to get the equation yourself, this is the process and this is what it will output. It will give you a and b. It will not actually plug it into the equation. They're requiring you to come up with that yourself. So this is just an example. Okay. So what I would like you to do right now, example 2, find the least squares regression line of the coordinates you put into L1 and L2. Does it match what the website showed? So I'd like you to actually try this on your calculator. You should already have those points plugged into L1 and L2 with your calculator. So all you would have to do, you've already done step 1. Go ahead and do step 2. Actually follow the instructions with your calculator and just check and make sure that it does match what the website showed. So you can pause this for a second while you all cry and troubleshoot about the errors on your calculator, and then go ahead and check your stuff. By the way, public service announcement yet again, if you guys are having trouble with your calculator, and I know like not every teacher knows how to do this. Like I didn't know how to do all this stuff on my calculator, frankly, until I taught AP Stats. Guys, your phone is your friend. Google how to do it. Say, how do you do a linear regression equation on your calculator? Just ask your phone questions. Guaranteed there are going to be YouTube videos and or instructions for how to do this stuff. So if you're ever lost with calculator instructions, please Google. Please. Okay? All right, so if you're unpausing this, you should have gotten the exact same equation. So the y hat they showed you, the a and b that they gave you should be, a should be 2, and then b should be 0.82, okay? So it should match exactly the same thing, should be good to go, okay? So at this point, this is sort of where I saw you guys stopping this lesson, and then continuing with part B and the rest of the notes tomorrow. So if you'd like to stop here, that'd be awesome. If you have a ton of time left in class, then by all means keep going. But I would personally recommend you stop here, maybe do some homework questions that correspond to this stuff, and then you can move on to residual plots tomorrow. Whenever tomorrow is. However, I'm going to forge on ahead, so if you need to stop the video, go ahead and stop it. You're at about 29 minutes, and if you are ready to keep going, then let's keep going. Okay. All right, so we now know what a residual is, and we are going to now move on to something called a residual plot. And it is exactly what it sounds like. It is literally a graph or a plot of all of the residual distances from the scatter plot. Okay? So So a residual plot is a scatter plot. So residual plot, excuse me, residual plots are scatter plots with the same x variable. Nope. Okay. With same x variable. So it's got exactly the same x variable as an original scatter plot does. So if you notice here, it's kind of small, but it says miles driven on the original scatter plot, and on this weird looking plot it says miles driven. Here, just x and x. It's got to have exactly the same x variable. And the y variable, the same x variable, and the y variable is, or are, residuals. Okay, so if you notice, for this scatter plot, like for example, this one that's kind of hanging out there all by himself, this guy right here. So this guy is right about at 70-ish thousand miles, and it appears to be about here. In fact, this might be our guy that we just found. So our y values here, our actual values here. Looks like our y value is about at like, I don't know, 22-ish thousand, and your predicted y value is here at about like 26,000. In fact, I think this is the guy from last time. So the residual for this guy is going to be about negative 4,000-ish. It's whatever it was from the last class. So if I move on over to the residual plot, I'm going to look for about 70,000. And if I notice, I have negative 5,000. Here is my residual. So this is literally plotting, hey, for this particular truck, this is its residual. So that's what a residual plot is. Okay. So, okay, preset, I found residuals, I plotted a bunch of them, who cares, why are we looking at this? Well, actually, residual plots kind of tell us a lot. A residual plot can actually tell us if our original data is fairly linear. And so here's sort of the idea. If your data is linear, then a line should do a good job of modeling the data. And if a line does a good job of modeling the data, then about half the points should be above this scatterplot line, and half the points should be below it, and it should sort of be evenly spread out. So like for the lower x values, there should be about half the data points above and below it. It should be about half. And then for the higher x values, it should be the same. I should have about half my data points above the line and half the data points below the line. So all this to say, if my residuals are kind of scattered around pretty well, so meaning about half of them are above the line, half of them are below the line, and it's like that for all values of x. So on this part of the graph all the way to this part of the graph. Then that means that a line does a good job of modeling the data. So if you notice in this residual plot, if you look at the plot itself, if you didn't know what it was, this just looks like a total scatter plot. It looks like there's no correlation. It's a blob. That's actually good. You want that in a residual plot. Because if the residuals are all over the place, that means that the original data is fairly linear. And so let's write that down. I know, sort of lots of arrows and whatnot. So if there is no pattern in the residual plot, and by pattern I mean no linear or curved pattern, in the residual plot, then original data is fairly linear, or maybe better than fairly linear. So if there is no pattern in the residual plot, like this guy, that's good. That means the original data here is actually pretty linear, and a line is gonna do a good job of modeling the data. Now if you notice here, this guy, this is your original data right here. If you notice, is this data linear? No, of course not. This is a curve. I can, in fact, connect all these points and make a curve. So this data is clearly not linear. Now notice about half of the points are above this line and about half the points are below this line, but it's not spread out. Here, you had points above the line when x was small. You had points above the line when x was big. Here, it looks like the middle x's, if you will, are all above the line and any extreme ends are below. That's not good. So if you notice, this data in this guy is not linear, and now, hey, let's look at its residual plot. Well, the residual plot's definitely got a pattern. It's got a curved pattern, in fact. Well, because the data in the residual plot has a curved, hey, eraser, why aren't you working for me? There we go. Because the data in the residual plot has a curved pattern, that tells you the original data is not linear. And of course, you can see that it is not linear. So, oopsie. So curves in the original, or in the residual plot, mean the original data is not linear. Okay? So that's nice. Let's fill in some more. So if the residual plot shows no pattern, once again, then the original scatter plot shows a linear relationship. Okay? Yet again, you are not going to have to make a residual plot by hand. Nobody hates you that much. You are going to use your calculator to make a residual plot. So here are directions for how to do that. So once again, step 1. So, and you need to make sure you follow these steps every time. Every single year that I teach this class. Some people forget to do this, and it's totally understandable, but don't let it be you. Don't forget this. So step 1 is always, you've got to put data in L1 and L2. And you're like, okay, Bree said, of course you do. Be surprised how many people forget. Step 2, you actually have to do what you did before. You have to press Stat. You have to scroll over to Calc, and you have to choose linear regression first. If you do not choose linear regression first, you are not going to get the right residual plot. So you're doing all of the steps that you did before. So Stat, Calc, choose number 8, Lin Reg, and press Enter. Okay? You're not going to use any of that data. Yet again, your calculator is going to spit out, hey, this is Y hat, or this is a A, and this is B. You don't care. At this point, you don't care. But you cannot find a residual plot unless you have done this first. Now, to make a residual plot from here, step 3, you are going to press second, and you are going to go to Y equals, so second Y equals. And again, you are going to choose the very first icon. Okay, so first icon. Okay, when you choose that first icon, it should tell you that you have an X list of L1, and you probably would from before have an X list or a Y list of L2. You actually are going to scroll down to the Y list of L2, and you are going to change it. So scroll down to where L2 itself is highlighted, and then you are going to press second, and you're going to press Stat, and it should say List on top, and you are going to scroll down until you get to the word Resid. And yes, that is Resid for residual. Now, some of you, Resid is going to be the very first thing you see. Others of you, you're going to have to scroll all the way down until you see Resid, and that might be not even on the screen yet. It might be the 8th or 9th option for you. Once you get to Resid, you are going to press Enter. And then your new Y list should actually not say L2. It should say, move this back for a second. It should actually say the word Y list. Should actually say the word Resid. Once you have all this, so once your X list is L1 and your Y list is Resid, then your last step is zoom, press zoom, and then actually press the number 9, or if you're old school, you can scroll down to the number 9. Okay, Hector Verduz go. Anyway, so that is how you are going to make a residual plot on your calculator. If you want to try this right now, in fact, it's not even if, try this right now with your original data, and you should get a residual plot that has little to no pattern. Now, you might end up, guys, seeing residual plots that have a little bit of a pattern, but we're talking comical. Like, check out this guy. That's a crazy pattern. That's what we're looking for, okay? So try that. You can go ahead and pause the video right now. Actually try to make a residual plot yourself. If you have issues, remember, you can't get the residual plot unless you have already run linear regression. If you haven't done StatCalc number 8 yet with the data you're trying to make a residual plot for, it's not going to work, okay? Again, everybody always forgets that. I will try to keep reminding you via these videos, okay? So, moving on, the next part, I think I'm going to have you sketch that plot. Yeah. Perfect. So now I'm going to have you actually sketch the residual plot. Oh gosh, reset. That was terrible. That's still not good. I hate Microsoft Word. So I'm going to have you sketch the residual plot from the calculator points that you had put in last lesson. So the way that we're going to label this is actually super easy. So you're going to label the x coordinate with whatever x values you have. And you're going to label the y with the word residuals. Okay. And not only that, but for AP, the only other thing you need to label is the line in the middle. And by the way, guys, why is there a line in the middle? What's that for? Yeah, that's for 0. Because, again, if we have a good model, that means that half of the residuals are going to be above the line, which means they're going to be positive residuals, and half the residuals are going to be below the line of best fit. They're going to be negative. So that means in the middle, it must represent a residual of 0. So what does it mean to have a point with a residual of 0? What does that mean? Yep. It means that the point itself actually does lie directly on the line. So if it has a residual of 0, that means that that point is exactly where you would predict it to be. Okay? So moving on back to this. So all you need to label a residual plot is the word residuals on the y-axis, whatever the x values are in context for your x-axis. Now, we literally just had x values. There was no context for us. And then you just need to label 0 in the middle of your residual plot. And then you're going to sketch roughly what your residual plot looks like. So mine, sketching from a copy I have, looks something like this. Got a couple down here. Got a couple up here. Right there. Big guy up there. And then like right here. There we go. So that's approximately what my residual plot looks like. I think yours should look-ish the same, but we shall see. Okay. So what I'm going to have you do now for the rest of this this lesson is you are going to now do this activity. So this activity should kind of put together everything you've done so far for scatter plots. And it's really important that you can do everything from this activity so far. It's not going to super ask you this activity. You're not really going to do anything super crazy. So if you're having trouble with any of these ideas, talk to your group, because this is sort of the basic skill stuff. We're going to get into the interpretative and analytical stuff in the next lesson. So I'm going to have you guys stop the video now, and you are going to do this entire activity, obviously with your group or by yourself, however you want to do this. And then your teacher should have a copy of the actual completed activity. And I'm going to have teacher, I'm going to have you go through and just show them the answers for this. If you guys want to take a picture of the answers after you're done, you go ahead and do that. But I want you to just check your answers, see if you got it. I'm betting almost all of you will. So that being said, go ahead and pause or stop the video. Actually, I'm going to stop the video so you are done. Do the activity, and then when you're done, check out the original, see how you did. If you did well, if you got pretty much all of it right, then you're golden. You're solid for the next couple lessons moving forward. Okay? All right, y'all.
Have a lovely day.